Okay, this is example 0.5 eh? Okay, again, so this one is already mentioned step by step eh? We want to prove step by step. First, we have normal distribution. So in this case, we have mean 0, variance theta. So that's mean your mu is equals to 0, your sigma square here is equals to theta. So this one case mu is known, okay, population mean is known. Case sigma square is unknown, where your sigma square here is equals to theta. So theta is unknown parameter. We want to show that summation xi square is a sufficient statistic for theta. So that's mean the first step, write down your likelihood function, your joint PDF, okay, and then split into two parts based on factorization theorem. We find the sufficient statistic. Okay, once you get the sufficient statistic, we want to find the expected value of this sufficient statistic. The reason that we want to find the expected value of this sufficient statistic because we want to show whether your expected value of sufficient statistic is equals to theta. If this one expected value is equals to theta, then it is unbiased estimator. Yeah. So part C, determine an unbiased estimator of theta that is a function of the sufficient statistic. Okay. Okay, first step. Kita tengok dia punya equation eh. You construct the joint PDF. Okay, joint PDF. So again, you have normal distribution, which means 0, variance theta. So you have fx theta. So the function is 1 over square root 2 pi theta. Yeah, exponential. Exponential. Negative x minus 0 square over 2 theta. Okay. So you have this one. So your mu is equals to 0. Okay. Your sigma square is equals to theta. So in this case, you need to find or you need to know the PDF function for normal distribution. Okay. Basic normal distribution and then substitute mu equals to 0, sigma square is equals to theta. Okay, we build up the PDF function. So that's mean you have 1 over square root 2 pi theta to the power n, and then we have exponential negative summation xi square over 2 theta. Okay, so in here I split 1 over square root 2 pi to the power n, theta to the power negative n over 2. Okay, square root 2, okay, square root half lah, half. So you bring up, so you have theta to the power minus n over 2. Okay, this one exponential negative summation xi square over 2 theta. Okay, we split, one depends on theta, the other one does not depend upon theta. Okay, based on factorization theorem. So by factorization theorem, so this is your hx, and then this is your function t. Okay, ini this is your hx, 1 over square root 2 pi to the power n. Ini function g, okay, function g. So theta to the power minus n over 2 exponential negative summation xi square over 2 theta. Okay, the value or the function of x1, x2, xn that depends on theta is this one. Okay, so by factorization theorem, our function t equals to summation xi square is a sufficient statistic for theta. Okay, itu first answer First answer, how you want to find the sufficient statistic. So that's mean construct your likelihood function or your joint PDF. So use factorization theorem and then find the sufficient statistic. Okay. We just write down the function x je. Okay. You don't have to write this one. This one, bukan macam ni. This is not your tx. Okay. This is not your tx. It's just summation xi square je kita ambil. Okay. And again, you don't have to take negative. Tx is equals to summation xi square. Okay. Okay, the next one for B, you want to prove that whether this one is unbiased. You want to find the expected value, sorry. You want to find the expected value of sufficient statistic. So your expected value is summation xi square. Okay, expected value of summation SI square. Okay, expected value of summation SI square. So you have EX1 square plus X2 square plus XN square. Okay. So since our XI is 0 and theta, so we have expected value of XI is equals to 0. Ataupun, okay lah, expected value of X is equals to 0 because your mean is 0. Your variance for X is theta. Okay, so use the formula variance X, formula for variance, you have your EX square minus EX and then square. So EX square, okay, this one 0. So variance X is your theta. So in this case, your EX square is equals to theta. Okay, so that's why we have EX1 square, EX2 square, EXN square is just n theta. Because you have theta plus theta plus theta, so altogether n theta. Okay? Boleh faham tak setakat ni? Any question?
Okay, boleh faham.
Ya? Okay, so
Boleh,
proceed.
boleh.
Faham.
Faham ya? Okay, second part. Okay. Since a sufficient statistic for theta exists, so we try to find estimated theta using MLE and show that it is unbiased estimator. Okay. Soalan dia tadi tu? Okay, the question C tu determine an unbiased estimator of theta that is a function of the sufficient statistic. Okay, you want to determine unbiased estimator of theta. So for this one, we use the concept for MLE. Okay, so yang the first part A tadi, we just show that summation SI square is a sufficient statistic without using the MLE concept. Okay, now, since we want to prove this one is unbiased estimator, so we try to find estimated theta using MLE. So construct the likelihood function. Okay, you already have your likelihood function. Take ln. Okay, so set equals to 0, differentiate with respect to theta, so negative n over 2 theta, negative summation SI square over 2 theta, so theta to power minus 1, so you have plus summation SI square over 2 theta square, set equals to 0. Yeah. So give to this one, theta.
Kita nak buat kerja sekolah.
Sekejap lagi, sekejap.
Handphone je.
Okay, sekejap lagi kita buat. Okay, makan.
Tapi aku
Sekejap.
mana nak buka?
Suruh abang buka. Okay. So since our theta head is equals to summation SI square over n, our MLE, so our MLE is just a summation SI square over n. So we want to find whether this one is unbiased or not. So that means you have expected value of theta head. So expected value of summation SI square over n, so 1 over n. So we already have expected value of summation SI square. So cancel out, you get theta. So that means your sufficient statistic, okay, ataupun your unbiased estimator, your theta head is a function of the sufficient statistic. Okay, because already we have sufficient statistic, summation SI square over, sufficient statistic is just summation XI square. So in this case, your MLE is summation XI square over n. Okay, but one-to-one function. So we prove that's one, expected value of theta head, we get theta. So that's mean unbiased of theta, unbiased estimator of theta, which is your theta head, summation SI square over n, is also a function of the sufficient statistic. Okay, itu yang part yang ketiga. Yeah. So first, we find the sufficient statistic. Okay, we find the sufficient statistic. Okay, we find the sufficient statistic. We prove that summation SI squared is a sufficient statistic for theta. Second part, we find the expected value. Okay, because the question asks you to find the expected value. Okay, we prove that expected value is equals to n data and so on. And then the last part, we want to show that determine an unbiased estimator of data that is a function of the sufficient statistic. So that's mean you find your MLE, differentiate with respect to theta, set equals to 0, you get your theta head. So theta head is also summation xi square over n, which is a function of the sufficient statistic. So now prove that expected value of theta head is equals to theta, because the question asks you to determine unbiased estimator of theta. Okay, to the punya solution.